Welcome back. So we are discussing various type of problems here. So let me discuss the third problem. Okay, this is also a different kind of problems. Consider third orbit of helium plus. So we are not using any relativistic dynamics approach, so it's totally non-relativistic. So that is also mentioned here, but I am not writing. The speed of electron in the orbit in this orbit is will be, it's given k equals to 9 into 10 to the power 9 constant. Okay, z is 2. Okay, these values are given and the speed is asked in n equals to 2, that means in this orbit, third orbit. Okay, z is 2 is given and Planck's constant is also given, 6.6 into 10 to the power 34 joule second. So these are information given here. Okay, so what is k? Okay, let me find out. Let me do the problem first, then we will understand what is the k and other things. First we have to consider the third orbit of helium plus ion. Why the helium plus? This is already we have discussed, because helium plus is a hydrogen-like atom. Hydrogen-like atom means it has only one electron, but in its proton, in its nucleus there are 2 proton and 2 neutron. So there are 4 nucleons, but around it only 1 electron is revolving. That's why it's a hydrogen-like atom, and we can use the Bohr's model for that helium plus ion because it's a hydrogen-like atom. Otherwise we can't apply that Bohr's atomic model, because in case of more than 1 electron there are repulsion between electron and electron. In that case we can't apply that. Okay, but this is helium plus. So z should be 2, that is already given. Now what we have to find out? We have to find out the speed of the electron. Okay, what was the formula? mvr equals to nh by 2 pi. So v is actually nh by 2 pi mrn. Okay, now we have to put the r, because r is also variable. If you remember, in our first problem we noticed what was the formula of r. This is the r. Here is z also, but for hydrogen atom there was no z, but formula of r is that epsilon naught zh square. Let me put it. So r is not proportional, epsilon naught zh square divided by, what was divided by, pi m square. So pi m square. So this is the Rn. So if you put it here, then you can obtain 2 pi m epsilon naught zh square and pi m square. So pi will be cancelled out, m will be cancelled out, 1 h will be cancelled out also. So it will be n square divided by 2 epsilon naught zh, something like this. So now directly you can put n equals to 3, e is the charge of the electron, epsilon naught zh, but that is very difficult actually, because these values are not provided. Epsilon naught you don't know, e you don't know, you can remember, but that values are not provided here. So we have to do in a different way that we should know. Okay, so how you can do that? If you look at the formula, there is z and there is n, there is z and there is n, vn. Okay, but here should be a n square. Here is also n square, I think, in Rn. If you use the original formula, there will be n square, because that should be, this is for the first Bohr orbit. This formula is for r is equal to 1. Okay, this formula is for the r is equal to 1. Okay, otherwise it should be here is n square. For n there should be n square. So there should be n square, here should be n square. So in that case here will be n square, here is, so n square will be there, yes, so 1n will be there, zh by n, z square. Okay, this should be like this. Okay, I think there is some mistake. Let me see what is the exact form, because I think one z is missing there. Okay, yes, so let me erase this part. This is correct, mvr equals to nh by 2 pi. We know this part, but Rn we don't know. Rn we needed, then we can put it. Okay, what was the Rn? This was the Rn. Okay, now you can use it. Then Vn will be nh divided by 2 pi m of Rn. Okay, so okay, correct. So now what will be cancelled? This will be cancelled, pi will be cancelled, will be cancelled. So it will be z square divided by 2 epsilon naught nh. So you can write that. Now you see that E is constant, H is constant, E is constant. Just Z and N are variable, epsilon naught is also constant. These are all constant for any atom, anything. So you can write that Vn is essentially proportional to Z by N, where Z is the number of proton present in the atom and N is the orbit. So here N is 3, but you know, you have to keep in mind that V1 even is 1 by 137 into C. If you remember this value, then you can do it easily. Otherwise you have to put the values of Z, epsilon naught, these values, then you can also define. But if you remember this, then it is very good. So Vn for hydrogen atom is actually proportional to C by 137N. It should be, because it's C by 137 for the 1, for Vn it should be C by 137N. Now for any atom it should be Cz divided by 137N. Other part is constant, right? So it should be Cz divided by 137 of N. So by using that you can, now Z is 2 and N is 3, then Vn proportional to 2C by 3 into 137, this like this. Okay, so you can now do the problem. What we have to need, that speed. But what is this k? K is actually, H is also given. Okay, it's actually not proportional, it's equal. It's equal. It's equal, right? It's equal, not proportional. Okay, if it is clear, let me again explain it. I think that V1 for hydrogen atom for Z equals to 1, it's actually C by 137. So V1 is actually, this is the general formula, so it should be Z is 1, so it is E square divided by 2 epsilon naught H, because Z is 1, N is 1. So this is actually E square by 2 epsilon naught H, but we need that V3 for helium plus, that is general formula Z square divided by 2 epsilon naught NH. Now Z is 2 E square divided by 2 epsilon naught NH is actually 3 into H, because radius is actually considered here. So 2 by 3 into E square divided by 2 epsilon naught H. So it is 2 by 3 and it is C by 137. So it's actually C is, we know, 3 into 10 to the power 8 meter per second. 3 will be cancelled out. It will be 2 by 137 into 10 to the power 8 meter per second, which is eventually obtained 1.46 into 10 to the power 6 meter per second. So this will be the speed. So here we can just, we have to remember these things, then we can do that, just V1 and Vn. So here, from here, to solve this question, two things are needed, that V1 for hydrogen atom is actually C by 137 and Vn for any atom is proportional to Z by N. If you know these two formulas, then you can easily do this. Okay, so let me go to other problem, the fourth problem. Okay, what is mentioned, the ratio of kinetic energy EK, let me write it, to the total energy ET of an electron in a Bohr orbit of hydrogen atom is, it's asked. 4 options are given. A is 2:-1, B is 1:-1, C is 1:1, and the D is 1:-2. Just we have to evaluate this and select the correct option. Okay, so one thing you know, ET is actually EK plus EP, that is known, right? So EK is the kinetic energy and EP is the potential energy. What asked, that they are asking that EK divided by ET, if I am not wrong, yes, EK by ET. So this was asked. Okay, so what was the, okay, ET is eventually the En, we find out for hydrogen atom, for any atom that's just En. And now what was the EK and EP? If you know this, then you can easily evaluate this. Okay, so En we know, and EK also we find out, EK should be half of mVn square. For same orbit, it must be for the same orbit, so it should be N, otherwise you can't for particular Bohr orbit. So it half mVn square. Now you have to put the Vn. What was the Vn? Just we have derived the formula of Vn. This is the Vn. So if you put, then you can obtain that EK should be half of mv square. Okay, so should be half of 1 by 4 pi epsilon naught Z square by Rn, just like this. Okay, this will be the EK. Yes, why? Because you know from that equation it should be balanced, two force should be balanced, right? So what was that two force? One is mv square by r, another one is Z square by r square. Then V square should be Z square by r. Okay, V square should be Z square by r. And if you do, then to potential energy also the come. Okay, let me know, here should be m. V square is actually mr. Now we need that EK, 1 by 4 pi epsilon naught will be there for SI unit, 1 by 4 pi epsilon naught is there. If you put it here, then you can obtain this equation, just will be cancelled out, and this is straightforward, right? So this will be the EK, this is EK. And what will be the EP, the kinetic energy, potential energy part? It will be 4 pi epsilon naught minus and Z square by Rn. This will be the formula. So if you add this up, then you can have En, that means E total. E total will be again 1 by half, just we are adding these two formulas, 4 pi epsilon naught Z square by Rn. So if you look at EK and ET are the same, just having a negative sign. So it will be 1 divided by -1. So it should be 1:-1. So here should be a minus. No, this is 1:1. This is correct. This will be the correct option, 1:-1. Okay. Yes. So now going to the 5th question. Okay, let me write the question first. Given the value of Rydberg constant 10⁷ meter inverse, the wave number of last line of Balmer series in hydrogen spectrum will be. Again there are 4 options. Okay, so now we have to use that formula. We have already used that. 1/λ should be equals to r into n2 square. Now this is for Balmer series, so this should be 2 and this is, in general we can write n. So this is r is given, r is 10⁷ and they ask the last line. So here we have to understand what should be the last line. Last line means it is coming to n equals to 2, but from n equals to infinity, then only it will be the last line, right? Why? These things we have already explained in our class. Let's say again, if you want to understand, this is n equals to 2, second Bohr orbit. When the electron coming from 3 to 2, n equals to 3 to 2, then the energy gap will be minimum from Balmer series, and that means that will be the first line. Okay, so then the line will be from n equals to 4 to 2. So last line will essentially signifies n should be the infinite. So it is actually just like this. So it is 10⁴. So they ask the lambda should be 4 into 10⁻⁻7 actually. Okay, no, they want to know okay, it's meter inverse. Okay, that means it's wave number, that is one nu bar, it's 1/λ, that is just 0.25 into 10⁻7 meter inverse. So it's the correct option is this one, B. Okay, so in this part also we have discussed some problems. Last part we'll discuss again 1 or 2 problems, and then we'll conclude this chapter. We'll cover the total theory part and the numerical exercise also. So then this chapter will be totally completed. Okay, so let me meet in the last part. Thank you.